do you want to signal me when I should start, or?
Yeah, I'll like do a thumbs up or something when there's a couple of people that come into the live chat.
Yeah, sure.
There's no attendees at the moment, so we'll hopefully build. Hopefully.
Hopefully. Mm-hmm.
No one.
Everybody's gone to bed.
I think so.
Oh, there's a question already.
Is it?
Oh, somebody. Yeah. Give it a couple of more minutes.
Sure.
Get ready. Oh, I'm getting messages with people joining, so that's good.
That's encouraging.
Yes.
We're going to do some hardcore physics tonight, by the way. Everybody's going to need a notebook. Adam's going to do some really long maths with you.
Yeah, Friday night, good time for doing all the maths.
Yeah, why not?
Okay, Dan, if you want to make a start, then we'll.
Yeah, sure. Good. All right. So good evening, everyone. Good evening and welcome. My name is Dan. I'm one of the astronomers at the Kielder Observatory. My job is, to welcome people to the observatory and to show them around and do educational talks, both at the observatory and away from the observatory. I'm an observational astronomer, so using telescopes to navigate the night sky. That's what I love to do best. I'm also still a student as well, studying a degree in astronomy and planetary sciences. Adam Shaw is also on the call tonight. Can you say hello, Adam?
Yeah, hello everyone.
So Adam has a degree from the University of York in astrophysics. Adam is here as my technical backup, if you like, for astronomy related questions that I can't answer because we know so much about the universe that how can we possibly all cram it in one head? So at the observatory we share that amongst 11 of us, and Adam's one of the people who works up there with me and also heads up our educational outreach program. So he'll be on answering your questions and giving a little bit of support later towards the end. So I first off wanted to start by introducing you to the observatory, what it is, where we are and why we're in the specific location that we're in. This is what we look like. You can see the front of the building just here, and there's the side of the building. That classic view that you get when you turn up to the Kielder Observatory, where just on the borders of England and Scotland, in one of the darkest skies in Britain. In fact, the darkest and largest expanse of protected dark skies in Britain, and it was the largest in Europe. Now, it's really important to have an observatory in dark skies, and that's because the stuff that we're looking at is sometimes really, really faint and incredibly far away. And if we look at that from a city or a town, it's really, really difficult for us to see the night sky because there's an obstacle in our way. And that obstacle is, of course, light pollution. Just like what we can see here, this is a city of London upside down. But this wonderful image, I think, is a brilliant demonstration of showing you just how much light a place like London, a gigantic city like that, can produce. And all of that light, all it does is cause a glow in the atmosphere, because our atmosphere is filled with molecules, with atoms that help us, separate us from space. And they're very, very good at being able to scatter light. We know that because when the sun rises on a morning, our skies go a wonderful shade of blue. That's called the Rayleigh Effect, light scattering through our atmosphere. Now, down here on Earth, if we shine light back up towards the atmosphere, then that light is inevitably going to scatter around as well. So being able to see the night sky from somewhere like London is very, very difficult. In fact, if you were in a place like London, or maybe just outside of London, a smaller town or village, this might be what your night sky looks like. A healthy glow to the night sky. We might be able to see some stars in the image, but it's not great because of all of that light pollution. So what would happen if you came to somewhere like Kielder, really, really dark place, move away from all of that light pollution and come to somewhere incredibly dark? I think your night sky will start to look a little bit more like this here. Look at the difference that makes. Thousands of stars that we can see in just that one tiny patch of sky. This is the constellation of Orion, and we're going to look at constellations in a little bit more detail with Virtual Star Tour in just a little while. First off, I want to just introduce you to some basics in astronomy. And when I say basics in astronomy, I mean, what is a star? Answer that simple question, just so we're all on the same page. This is where, by the way, up in the northeast, just above Newcastle, which you can see just on the screen there, about, I think, the largest expanse of protected dark skies in Europe, 1,500 square kilometres of protected dark skies. That just means that everybody switches off their lights and replaces their lights with really, really nice downward facing lights that make sure that we don't shine as all of that light pollution upwards and up the way. Okay, so stars. Now, you might be thinking, why have I got an image of the sun? And that's because our sun is a star. The sun is a star. It's just our closest to us. All of the other stars in the universe, they're all suns just like ours. Much of them are very, very big, much bigger than our sun. And there's a whole heap which are much, much smaller than our sun as well. So it is absolutely a star. And an incredible, incredible object it is. It looks really big to us, but actually there is much, much bigger stars out there. Things like Pollux and Sirius and Rigel, Aldebaran and Betelgeuse. These stars are absolutely huge. Our sun is about just under 1 million miles the width of the Earth, which makes it about 109 times the diameter of our tiny little planet. And on the right hand side of the screen there, actually, you can see a comparison with just the edge of our sun and that little tiny Earth. Look how small it is compared to the actual size of our sun. And then stars like Betelgeuse, they're massive. That star is 890 million miles in diameter, which makes it, well, if you put it in our solar system, it would come out as far as the orbit of Jupiter. This star is massive. So there's some really big ones out there. There's also some really small ones. Now, what's it doing? Why is it alive? It's approximately 4.5 billion years old is our sun, which is quite an age. And for the last 4.5 billion years, it's been doing this thing that we call hydrogen fusion. There's a lot of activity taking place deep inside our sun, which is causing these energetic reactions. Hydrogen fusing together to create helium. Now, hydrogen is the most basic ingredient on the periodic table. Number 1 on the periodic table, in fact, the most abundant element in the entire universe. So lots of that kicking about. Surely there's lots of stars. And absolutely there is. And they develop in these clumps which are contained within these things that we call, now is it going to skip to the next page? There we go. Nebula. Now, you may have seen this image. This is an image of the Orion Nebula. A big, gigantic gas cloud. This gas cloud is huge, 24 light years in diameter, in fact. Now, if you're not entirely sure what a light year is the measurement of distance to a particular object. So when we talk about light years, we're talking about the distance to something. And in this case, 1 light year is just under 6 trillion miles. So it's a pretty long way. So we've got 24 of those in diameter is this gigantic big gas cloud that we can see here, the Orion Nebula. Loads and loads and loads of hydrogen gas. And under the right conditions, those hydrogen fusion reactions are starting to take place and suns are coming to life, being born in these gigantic gas clouds. Then beyond that, these gas clouds also contain some other elements within them as well, elements which are heavier than the hydrogen gas that we see in abundance in the big scale structure. Those elements go on together to create these the planets around the suns, around these brand new stars. So when you see these big clouds of nebula, there's brand new stars being born inside those things, brand new worlds being born around those stars as well, out of all of those ingredients from a recycling process in the life death of our universe, which we're not going to cover just now. So that was a really quick whiz tour on stars. And we covered that in just under 10 minutes, which is pretty incredible. And if you want to ask any more questions on the specifics of stars, then we can cover that in the Q&As towards the end. But first off, before we do that, and before we look at constellations themselves, I just want to tell you a little bit more about constellations and what they are and why they're important. They've been around for a very long time. They've been around for thousands of years, and in fact, in some cases, we can trace back some of the very early depictions of constellations up to 10,000 years in history. Some of these cave paintings that you hopefully should see on your screen right now date back to around about 4000 BC. They're really, really old depictions of of constellations. And this was an ancient civilization that was trying to make sense of the night sky. They were doing a dot to dot, essentially, with the images, with the stars that they could see in the night sky. They were tracing out images and pictures amongst the stars because they didn't know what they were back then. They hadn't even left probably their countries in this particular era, or even maybe their small vicinity of maybe 100 miles in diameter. These people were very primitive, very early man. And when they were looking up at the night sky, they were trying to make sense of it, trying to give them their stories. And this is where we start to look at the different cultures. The different cultures have different constellations attached to them. However, that became a little bit too confusing. And in the early 1920s, the International Astronomical Union, a group of people, decided that we would have 88 universal constellations that we would talk about as an entire planet. So now we have 88 official constellations, which are on your screen right now. It might look like a big complex mess, but that's because we just need to envisage them a little bit more. And we've got a piece of software that'll help us do that in just a second. Now, this is all 88 constellations that we see on the screen right now, but we don't get to see all of these. Not in the Northern Hemisphere, because remembering our planet is in fact spherical. And being spherical means that we can't see the universe or the galaxy on the other side of the planet or in the Southern Hemisphere. So in the Northern Hemisphere, this is our view. This is the constellations that we're most used to seeing. The Southern Hemisphere would have a completely different set of constellations. Now, years ago, hundreds of years ago, sailors used to use the techniques of stargazing and positions of different celestial objects, whether that be the moon, the sun, or indeed a particular star, in order to be able to find their way around the globe. Because by using the constellations, you can find out which direction you're going, and even to some degree, what latitude you're at on our planet. So it's a really useful tool to know what you're looking at and to know where things are in the night sky. If you had no maps, no GPS, nothing like that, how would you navigate if you had no way of being able to reference anything around you? There was no fauna, just lots of sea or lots of desert. Well, you would use the stars. And they would use these particular tools in order to be able to do that. And the constellations were really useful, but there was one particular star in our night sky, which is really, really useful for us still today. And that's our North Star. If you find the North Star you know where north is. You can at least determine where the northernmost point of axis of rotation is, or the North Pole is. And then you can kind of work out somewhat roughly where south is, or where east is, and where west is. So it's really useful being able to find the North Star. And Polaris looks like this. Now, how do you find it amongst all of those other stars? And we're going to look at how you find it in just a few moments' time. And first off, I want to just show you this little animation, because Polaris, the North Star, that's right in the middle of the screen there. If we were stood on the North Pole, that star would be right above your head. Now, our planet is spinning round, which means when we look at the sky over the course of minutes and into hours, the sky does move away from us as our planet spins round once every 24 hours, which is what allows us to take images like this. If we keep taking exposures, we can see the physical rotation of our planet as it spins round once every 24 hours. Now, you might notice, some of you with a keen eye might notice that Polaris has drifted a little bit, and that's because it's not perfectly in the right spot, but it's good enough for us to be able to determine where the north is. So we'd still refer to it as our North Star. Okay. Now, there's another thing that I want to show you just before we move into the observations, and that's just to describe a little bit more about the way that the solar system is configured. We're all going around the sun, all of the planets, they're all going around our sun. And if we look at it top down, this is what it looks like, almost like a record disc. And interestingly, if we look at it from a different angle, so if we make this go, which is hopefully what's going to happen. There we go. We can see that if we look at the solar system from the point of view of our planet, all of the other planets are almost on a flat disk-like plane, with the sun in the middle and the planets almost going around on a flat disk. Again, almost like a record spinning around on a record player. Now, the sun over there, we can't see the stars on the other side of the sun because the sun's there causing that Rayleigh effect and scattering all that light. But as we rotate around to see the nighttime side of our sky, these are the constellations that we can see on a nighttime right now. Now, not only are we spinning round, but we're also going around the sun. And what that means is our current place in our solar system is the constellations that we're able to see at this time of year. But when it gets later in the year, we'll have moved position around the solar system. We'll have moved to a different part of our solar system. And as we move to a different part of our solar system, we'll see a different part of the galaxy. We'll see different constellations. So the constellations aren't the same all year round. The only ones that will stay the same for us are the ones towards the north. Some of them may dip below the horizon, but the south will ever change throughout the course of the year. And there's some really interesting constellations that I want to show you that will help you identify what time of year it is if you weren't already able to guess yourself whether or not it was warm or cold. Okay, let's move on to the virtual stargazing then. We're a piece of software called Stellarium, which is on the screen right now. You can see it there. Stellarium you can download from stellarium.org for free for your computer, Windows, Mac and Linux. And you can also download it for your phones. However, I think it's like £2 for your mobile phone or for an iPad. The benefit of having it for your phone is that you can hold it up to the sky and point it at a particular object and it'll tell you what it is. Now let's try and swap the screen sharing and see if we can get the Stellarium screen. Let me just press a different button. Give me 2 minutes. Let's see if we can share a different screen. That's all right. It's not working. There we go. you should be able to see the Stellarium screen. Can you see that, Oliver? Just check in to see if we can see that. Is that a yes?
Yeah, all good.
Yep, great. Get it to work first off, so just wanted to check. Great. So now what we can see is our night sky. So this is what it looks like above our head right now. This piece of simulation software will simulate the night sky wherever you are on the planet. You could even, if you wanted to, jump to a different place. Maybe you wanted to jump to a different hemisphere. Look at what the sky was like in the southern hemisphere. But for now, we're going to concentrate on our night sky right now. Now, we can't see that many stars because in the summertime, unfortunately, where we're placed in the UK, the sun is still over there somewhere and it's still causing a bit of a disturbance on our night sky. But we can still see some brighter objects. Stars such as this one over here, Spica, which we can see a very bright star just over there. And then if we spin round to the west, we've got a couple of stars disappearing over here. But what I want to show you first off is just these two objects right down here. You see these in the northwest, just off to the northwest right now. If you've got a really good, clean, clear view of your horizon, you might just be able to spot these two objects, these two planets, very close to each other. We've got the planet Venus and the planet Mercury just over there. Look, planet Venus and planet Mercury, those two bright objects. Venus is very, very bright. Mercury is a little bit dimmer. And over the next coming days, Mercury will be getting a little bit higher. So we'll be able to see it with greater detail. After sunset, we'll be able to see this little star trailing behind the planet Venus. That little star, that little dot of light is the planet Mercury, the one closest to our sun. Venus has been around for a good few months now. Very, very bright star off towards the west just after sunset. In fact, we have a lot of people who often message the observatory and say, what's that big bright star off towards the west? Is it aliens? No, it's not. It's Venus. It's all right. Don't worry about it. So Venus over there towards the west and Mercury. Those are things to look out for over the next week or so if it's nice and clear towards the west. Now, constellations and the way that we will build up that picture using a piece of software like this is really, really easy for us. And what I'm going to do is I'm going to press a particular button which will eradicate our atmosphere. So it's going to delete our atmosphere so we can see as it would be without an atmosphere. This is what it would look like. Look at all these stars. Imagine having no light pollution, no atmosphere. And to be honest, a Kielder, I've seen it look pretty good like this before. It's looked pretty spectacular. And Adam and I, in fact, went on a stargazing holiday last year. And when we did, the sky was very much like this in Tenerife, an incredible, incredible sky. So how do you start to make sense of all of these stars? We start to make pictures of them. And when you start to build up your imagery of the simple ones, then you can start to build up the bigger pictures. Or if you find anchors in the night sky of brighter stars, then we can start to trace the outlines of these more complex constellations. We'll start with this one up here. I've got a star towards the southwest at the moment called Regulus. It's a pretty bright star, which you'll see right now outside. Now that star, that is the front paw of the constellation of Leo, the lion, who looks like this. This is what the constellation boundaries or lines look like. So the front paw of Leo, and you can see that he looks like a backwards question mark. So if you trace up from Regulus and we make that backwards question mark almost like hook-like shape, that creates the mane, the head of Leo, that then traces back into this triangle at the back here. It's supposed to look a little bit more like this. This is what it's supposed to look like. So we've got Leo the lion just there. Look across to the right of Leo, we have Cancer the crab. Now, Cancer is an incredible constellation, and in fact, one of my favorite constellations. And at the moment, if there's no moon in the sky, and you have a good pair of binoculars, there's an object which I would really encourage you to locate with this software. And that is this lovely section just in the middle here. This here is called the Beehive Cluster. It's an open cluster of stars inside our galaxy. They look really close to each other, supposed to resemble bees buzzing around a hive. And it kind of, I guess, when you see it closer, without this artwork on, let's take that off, it kind of does look like that. Imagine using your creative mind to imagine these little stars as bees flocking around a little hive. That's what we've got in the middle of Cancer, the crab. We've also got an incredible star in here as well, which Adam will probably recoil in laughter when I mention this one, because this requires a very powerful telescope in order to be able to see it, or a reasonably powerful telescope. In fact, if you have an 8-inch telescope, you'd probably be able to see this star. This star, I only know it by its official name and not this fancy name that the software is using here, but HIP 43103. It's a really interesting star because it looks like one star to us on the screen right there. But if we look at it through a telescope, and hopefully I'm hoping this is going to work, when we zoom in on it, look, it's not one star, it's 2 stars. This is what we call a binary system. 2 stars orbiting around each other. If you've got any Star Wars fans in tonight, then this could be the place, very similar to that of Luke Skywalker's home planet, the one with the 2-star system. Imagine being on a planet around this star. It would be incredible seeing these 2 stars in your daytime sky. So HIP 43103, the top claw of Cancer, the crab, is a wonderful star to locate with a pair of binoculars. Now, just before we move on to some navigational points, I just want to show you the rest of the constellations in the southern part of the sky right now. In particular, one which is rising towards the left-hand side over here, towards the east. Over here, we have a very bright star called Vega. Vega's super bright. You'll see that across towards the northeast, well, eastish, around about now. If you went outside and it was nice and clear, you'd see in the east, lovely bright star, maybe about 2 hands widths above the horizon. Beautiful star to look at, and beautiful star to look at through a pair of binoculars as well. Now, if we trace a different shape around this using that star, we can start to make out this thing we call an asterism. An asterism isn't official constellation. It's just a shape drawn of bright stars for a different reference. So we've got Vega, which is nice and bright over there. And then we've got Deneb, which is to the left of Vega, a star just a little bit dimmer than Vega to the naked eye. As the night goes on tonight, oops, my screen's gone funny. There we go. As the night goes on tonight, so give it maybe another, let's have a look, maybe another hour or two, maybe another hour. Another star, another bright star, will start to rise over the horizon as well, called Altair, which we can see just above the E, down at the bottom of the there. Altair, Deneb, and Vega make it. Now, this time of year, that's when these stars start to rise up to the central point of our sky at midnight. In the height of summer, this asterism will be almost perfectly in the south position of our sky at midnight. And so we call this the summer triangle. And the reason we call it that is because if you didn't know what season it was and you needed just a reminder on what season it was, if you were in a very warm country that was just warm all year round and you thought, oh, what season is it? I'm not entirely sure. I haven't got a calendar on me. I'll just have a look at the sky. You will be able to see that it will be summertime by spotting the summer triangle. The summer triangle always points south as well. So that triangular tip points towards the south, or a southerly direction. You might also be able to see a bright band of light running through that summer triangle. Now, this is an incredible thing to see. And if you live in southern parts of the UK, or even further south than the UK, and you don't have the problem with the sun not setting on a nighttime during the summertime, this is the time of year where our Milky Way is best viewed. Absolutely incredible view of the Milky Way from June onwards if you live in further south places. And that's because the central structure of our Milky Way galaxy is moving across our sky. That band of light that we see there is the disk of our galaxy. Remember, we were talking about how the solar system is a flat disk-like shape, but the rest of the galaxy is also a big flat disk-like shape, or somewhat flat disk-like shape. So when we look down the disk's plane, we see all of these stars, which create this big bright band that stretches across the night sky. And that's what we call our Milky Way, which is what we can see across the sky right there. And as the night goes on, that'll raise up higher and higher and higher. So if you do live in more southern places in a very dark sky condition, around about 20 to 1 tonight, your sky is going to look absolutely incredible. We're going to be able to see that central bulge of the Milky Way down towards the south just there. Okay, one last thing before we move on to the question, which is how to find north. That's the one thing I want to leave you with. So let's have a look at our north. How would you find it? Well, there's a constellation that we can use called Ursa Major. That's this one here. It's made up of these stars that look like a bear. It's supposed to look like a bear. Look like a bear, do you think? Maybe, or a frog or something. We don't want to use the whole thing though. We just want to use 7 stars, in fact. We want to use these 7 stars at the back here. Recognize these? I reckon that if you're a stargazer or you have a slight interest in astronomy, you're going to know that. That there is our plough, or the Big Dipper. The saucepan or the frying pan. Now, if you find that, we want to find the 2 end stars here. These we call our pointer stars, Merrick and Doobie. Draw a line through them that extends up out of the top of the pot to that star right there. And that is Polaris. So if you go outside right now and you look up at the sky and you find the plough, you'll be able to find Polaris in an absolute crack. Okay. Now, just before we move on to questions, let me just flick back to my screen. And I want to give you 2 things which I recommend for stargazing. Nope, that's the wrong thing. This is the right thing. There we go. So stargazing from home, we recommend a pair of good binoculars if you're spending around about 100 quid. Ones which are 10x50 or 10 times 50. These are the ones that you want to be investing in for a good pair of binoculars. Don't buy a telescope at this point. Stick with binoculars. If you want to buy a telescope, the cheapest telescope entry point is about £200. The one that we recommend is this one just here. This is a Dobsonian telescope, in particular the Skywatcher Skyliner 200p. Incredible telescope for back gardens. Really easy to use, no complex setting up of mounts or anything like that. You just plonk it down, spin it round, point it at what you want to have a look at, and it'll look great. Lots of diameter, which is what we want with telescopes. The wider the diameter, more light, the better we can see. And the stuff that we're looking at, remember, is really far away. Okay, that's it from me then. Any questions, Adam?
Yeah, we've had some absolutely amazing questions throughout your session. So I've answered some of them in the Q&A, but I've got some set aside for us to answer now. And if I want one question that we started off with, a couple of people asked, what do people need to study to become an astronaut? So for that, straight away, I would just recommend maths and physics. Just doing maths and physics, that gets you kind of in the right topic. I mean, maths is needed for physics really, and from physics you can then go into astrophysics, which is more directly related. But a question I think is good for both of us actually is someone's asked, what is the best part of astronomy? So Dan, what do you think is the best part of astronomy?
I think it's the feeling, to be honest. The constant. I mean, I'm one of those people who likes to know the ins and outs of absolutely everything. And the thing that the thing that irritates me with astronomy is that it's impossible to know the ins and outs of everything. But because it annoys me, that's what keeps me hooked on it, is because I just want to learn more. And I'm kind of satisfied just sitting and looking at the night sky and just taking it in without wondering or thinking too much. I can just look up using the limited knowledge that I know about already and enjoy the night sky as it is, as a beautiful thing. It's a rather wet answer, but I think that'll do.
Answer.
Yeah.
See, personally, I would say it's. I mean, the best part is when the rare things happen. So if you see a really big shooting star meteor going across the sky, a really bright one, or or it's just a perfectly clear night and you can see thousands of stars in the sky. It's got to be seeing it with your own eyes, in my opinion. Just something special.
Yeah, it's really peaceful. I remember when we were sat on the mountain last year, that was the most incredible thing, was just being able to sit there and just look at it and go, wow. And your brain just goes blank.
You just can't absorb it all. But okay, another question for both of us is, how did you get involved in this career? I think I'll answer this one because I feel like mine's a bit boring, to be honest. But personally,
yours is a more classic approach.
Yeah, exactly. Mine's the more classic approach, whereas yours is a bit different. So I ended up doing this job from being at school, doing maths and physics, as I mentioned. And GCSE, and then to A level, I studied maths and physics, and then I went to university and I studied physics with astrophysics, in fact, so specialising in the astronomy, the astrophysics side of things. And throughout doing all of this, I had my own telescope. I was involved in doing a lot of astronomy. I was looking up at the night sky, really. And then whilst I was at university, I started running events. I started teaching people about astronomy, showing people things through telescopes. And then I just ended up working at the observatory because that's exactly what I enjoyed doing whilst I was a student. So just sharing something that I'm interested in with others. But Dan, you went down a different route, didn't you?
Yeah, I never left. Yeah, that's why I ended up with the job. So my background is at uni. I studied theatre, and then I spent some years in retail, and then some years in commercial radio. Then I opened a cafe, and the cafe was a geek-themed cafe. A cafe it was the first comic book and gaming cafe in the North when it opened around 6 or 7 years ago. And I ran that for quite some time with my other half. And stargazing has been a passion of mine for very many years. And we went to the observatory about 4 years ago, maybe 5 years ago, touching on 4 or 5 years ago. And we kept going back instead of, because I don't drink, I'm teetotal. Responsible adult, and so instead of going out at the weekend, we used to go to the observatory, and it was incredible. And we got hooked, and I got to know the team, and then I started volunteering, and then I was offered a full-time job. The cafe sadly closed a couple of years ago. And I've been on the team since then. So it's totally different route to Adam. Doesn't mean that you can go and do what you want if you want to be an astrophysicist or astronomer or anything like that. It's just I fell into it. It's very, very fortunate, very rare situation. And now I'm having to play catch up by studying in my spare time.
But at the same time, whilst it's a different route, you got here because you were interested in a subject. You pursued it, you kept on going at it, and well, now you're doing it as a job. So
yeah, absolutely, it's perseverance, isn't it? And just education is the most important factor in all of that. Yeah,
absolutely. Okay, so another question. If a few people have asked about this, what's going to happen to the sun when it dies? I saw someone mentioned about it turning into a black hole, but that's not actually quite what happens. Really big stars, when they die, they explode in what's called a supernova, and then the biggest stars, after they explode, they can then collapse back down and form a black hole. But our sun's not that big. It's a sort of medium star. It's a medium size. It's a medium temperature. It's not that special really compared to all the other stars in the sky. But when our sun dies, and this will be about 4 or 5 billion years from now, so don't worry about it. It's not going to affect us. It's going to get really big. It's going to get so big it will end up eating the planets Mercury, Venus, and probably Earth as well. So that's how our planet is going to end, unfortunately. But again, 4 or 5 billion years from now. But then after that, it's just going to sort of fizzle out. It's getting so big that the outer parts of the star will expand, and then the core, the middle of the star, will just remain in the middle as a really hot fading remnant, sort of fading remains of the dead star, known as a white dwarf star. Okay, so Dan, Thomas has asked, in fact, when's the best time to visit the observatory?
Oh, well, it depends if you want to come when it's snowing or when it's covered in midge. To be honest, my favourite time of year is actually around about now, and a lot of stargazers will completely disagree with that because there's not many stars and not many deep sky objects and stuff to see. But at this time of year, you've got planets which start to come back into the skies around June and July. We've got Jupiter in June and July, towards the end of June into July, and Saturn coming back into the skies. Beautiful things to look at through our telescopes. And noctilucent clouds, which are incredible phenomenon. I love to see noctilucent clouds. They're shiny, glowy clouds on a night time. Aside from that, the proper hardcore stargazing time, February, but it snows. So you're kind of in the situation whereby it's really cold and potentially snowing, but you're doing some incredible stargazing.
Yeah, I'd agree with everything you've said. I mean, it does boil down to preference a little bit, doesn't it?
Yeah.
So I really like the autumn time personally, and then going into winter. I mean, the dark nights in winter, you can't beat those. So anyway, so basically, all year is great. So another person, a question. Finley has asked, how many planets are there? See, in our solar system, there are 8 planets. There used to be 9. Poor old Pluto got demoted. Pluto's now a dwarf planet, and there's quite a few other dwarf planets in our solar system. But there are 8 planets, so Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That's 8 right there. However, we found a lot of other planets around other stars, and this is something that really excites me. These are called exoplanets or extrasolar planets, because remember, the sun is just a star, and all those stars in the sky, they are just like our sun, and we think that pretty much every single star has at least one planet around it. Astronomers are finding new planets pretty much every single day at this point, but so far astronomers have found over 4,000 of these exoplanets. Yeah, so Dan's just pulled up a photo of the observatory with the night sky above it. Look at all of those dots, little tiny dots, those little grains of sand. Every single one of those probably has a planet around it, and probably multiple planets as well. So there are a lot of planets, basically. But on a sort of similar topic, Albert asks, is Pluto classed as a planet? I gave a hint about that one there. But Dan, do you fancy explaining a bit more about why Pluto is a dwarf planet?
Yeah, so Pluto Pluto isn't a planet anymore. Well, it is a planet, but it's just not categorized as a full-size, fully fledged planet, if you like. It's now a dwarf planet. Part of the reason of that, and correct me if I'm wrong here, is that it hasn't cleared its orbital path. Am I right with that?
Yeah, absolutely.
Got to check that one, yeah. Because I always forget some of the parameters that it is to be a planet, and it does need a specific set of criteria, and one of those is to clear its orbital path. So to do one revolution without any debris and such in it, and it hasn't done that. So it's not a planet to us. Is that right?
Yeah, absolutely. So it would need to collect up all that debris, all those rocks, those asteroids, everything that's out there. In fact, there are other dwarf planets out where Pluto is, and it's an area called the Kuiper Belt. But it basically boils down to it's too small and need to get all of these other things to be classed as a planet. So there are a few questions that all sort of link together a little bit, because Oliver has asked, what are the best places for stargazing? And an anonymous person has asked, does pollution give you a disadvantage in seeing stars? And you see, I'm going to take that and rather think about literally pollution, but think about light pollution in particular as well, because that ties into best places for stargazing. And then another person, an anonymous person, has asked, how many stars can you normally see? So for that, I think you'd agree with me, Dan, that the best places for stargazing is far away from light, far away from the towns and cities. So just get somewhere dark. So our observatory is on a hill in the middle of a forest, in the middle of nowhere, outside the remotest village in England. So it is very dark there. And I mean, you can see that photo right there. You can see thousands of stars above it. So just far away from towns and cities, because light from towns and cities, street lights, houses, buildings going up in the sky, that washes out all the stars. And as a result, you can't see as many. You know, if you're standing under a street light down on your street, you're not going to see many stars up in the sky. So that's what we call light pollution. But from our observatory, correct me if I'm wrong, Dan, but I think the number that you can sort of see is about 2,000-3,000 stars with just the naked eye alone.
Something about that, yeah.
So you can literally see thousands of stars. Then if you have a telescope, depending on how big your telescope is, the limit is pretty much endless. So I'll go for one more question. Someone's asked, is Sirius known as the dog star?
Yes.
Yes, it is.
So,
yes.
Yeah, some of you might notice some of you might notice the link here as well between the Harry Potter character Sirius Black, who turns into a dog. So this inspiration came from that constellation. It's in a constellation called Canis Major, or it's a big dog, and it sits in the collar, the neck of Canis Major, does Sirius. Very, very bright star. In fact, it's the brightest star in the nighttime sky. And J.K. Rowling, she took a great interest in astrology, which is a totally different subject to astronomy. I should make that really clear. But she took an interest in astrology, and so she brought some of the names of stars and constellations and such into her characters. Draco, Bellatrix, Sirius, all names of stars or constellations.
Okay, so I did say that was going to be the last question. However, I just realised that there's a good one that I've missed out that I know that you will love to talk about, Dan. Thomas has asked, when is the best time to see a shooting star? Because you see, guys, Dan actually loves shooting stars.
I really do, yeah. Shooting stars are one of my favourite things, and meteorites, the thing that they produce at the end. Some really, really good shooting stars throughout the year, or meteor showers throughout the year. The Lyrids actually is a really nice one, which has just passed in April. Towards the end of April, there's a particular meteor shower called the Lyrids, which is a really, really nice one. We get some really bright shooting stars from that. The next really good one to watch out for, that's going to be the Perseids in August, isn't it, Adam? I don't think there's anything between us and the Perseids.
Mm-hmm.
Yeah, so the Perseids is a really good meteor shower. The problem is, if you live in northern parts of the UK, it's not perfectly dark enough for us to be able to see a great deal of them. If you live in more southern parts of the UK, you've probably got a better chance of seeing more shooting stars in the darker skies down there. And the one after that, the next really good one after that, has got to be the Geminids, maybe, which is towards December time.
Yeah, absolutely. I mean, the Geminids last year was really, really good. I mean, we were talking about light pollution before. To be able to see the really good shooting stars, those meteors, those streaks in the sky. Ideally, you want to be where it's as dark as possible. Last year, the Geminids meteor shower in December, that Dan's just mentioned, there was a big bright moon in the sky, and no matter what you do, the moon gives off a lot of light. That's reflecting from the sun, of course, which does stars, unfortunately. But even then, I don't know about you, Dan, but I was outside during the Geminids meteor shower last year and just saw hundreds of them up there.
It was a good one.
Absolutely amazing.
Very good one.
Okay, so we've had some fantastic questions there. So I think, should we finish up there?
Yeah. Yeah, good. So that's it. Thanks very much, guys, and thanks for joining us on this evening. And get outside and do some stuff. Actually, no, go to bed.
Thank you for the amazing questions, everyone.
All right. Thank you.